Good morning, friends. It's Miss Williams, and today I'm going to show you a little bit more about compression. So far we've seen an example of syringes that were filled with a solid, a liquid, and a gas. But maybe you haven't seen a syringe before or used one. So I'm going to use an example that's a little more familiar to us, and that's our water bottles. So as you can see here, this water bottle is filled pretty much with water, a little bit of air in there. And this water bottle is empty. But it's not really empty because it's filled with something else, right? It's filled with air, okay? And so today we're going to think about compression. So we think of that word press, right? We see press and compression, putting pressure on something. So when I compress or when I put pressure on the water bottles, let's see what happens to them. Okay. So I've got my one filled with air. And you can see when I put pressure on it, it kind of squishes together. Right? And I want you to think about what's happening with those molecules in there. Because we know air is matter. We know there's stuff in there, right? We know there's oxygen and hydrogen and all sorts of different gases moving in there. But I can still squish it even though there's stuff in there. Okay, now let's look at the water. Let's see what happens when I try to compress, when I try to add pressure to that water. So it moves a little bit, but not as much as the one filled with air. So think about why that's happening. Why does one compress more than others, even though there's matter in both, even though there's something inside of each bottle? So think about what air looks like, and what water looks like, and what the density, how tightly packed the molecules are in each of them, and why compression affects this bottle much more than this one.